welcome to this video. And in this video we're gonna do an example on the special multiplication rule. Okay, so we studied get this here. So we studied special multiplication rule. Okay, multiplication rule of probability. Okay, so by special multiplication rule, what I mean is the multiplication rule for independent events. Okay, so this is multiplication rule for independent events. Does that make sense? Okay, so by special multiplication rule I mean multiplication rule for independent events. So if we have two independent events, let's say A and B, then for the special multiplication rule what happens is probability of A and B, meaning probability of A intersection B is equal to probability of A times probability of B. We already know this, we have studied this in a previous lesson. Okay, and today we're gonna do an example on this. Okay, so let's start. Let's give you an example problem on a special multiplication rule. Okay, so the example problem is this: C and D are independent events. Okay, if probability of C is this and probability of D is this, find probability of C and D. So this implies intersection. Okay, so probability of C intersection D, and this is going to be nothing but probability of C times probability of D, and probability of C is 0.7 times probability of D is 0.6. so if you multiply them, what are you going to have? 0.42. okay, so it means the probability of C and D both happening is 42%. okay, 42%. So if you want to write them in terms of percentage, you can write. Okay, so this was a simple example. Let's give another one. Okay, another hard example than this. Okay, so the next example is this. Okay, so there is a roulette wheel. Okay, and the roulette wheel is spun, and on the roulette wheel there are 18 red numbers, 18 black numbers, and 2 green numbers. Okay, in total, meaning the size of the sample space is 38, and what you have to do is you have to find the probability that if the roulette wheel is spun, then the ball lands on red for the first time, and for the second time it lands on green, and for the third time it lands on blue. Okay, so you have to find the probability of this, and are those events independent or dependent? Then we for sure know they are what? Independent. It means that in the first spin, okay, in the first spin, if the ball lands on red, it does not influence the probability that in the second spin whether the ball will land on black or green or red. Okay, so it doesn't influence. Does that make sense? So it doesn't influence the probability. It means they are independent events. So what you can do is this will be probability of R times probability of G times probability of B. Okay, and probability of red is going to be what? 18 over 38 times probability of G, 2 over 38 times probability of B, 18 over 38. Okay, so if you simplify this, so what this will become, I can write this as 9 and 19 here, and yeah, this will be 19 and this will be 9, 19. Okay, so if you compute, let's multiply them and divide by so where is the calculator? Okay, so if you simplify this, we can have approximately this equal to 0.012. It means 1.2%. okay, so 1.2% is the chance of this event happening. Okay, so enough of examples. Okay, so I guess you have understood the concept of independence. Okay, so multiplication rule for independent events. Okay, now I'm going to clarify a confusion. Okay, so many people get confused about this thing, this concept, and the concept is that mutually exclusive, difference between mutually exclusive and independent events. Okay, so yeah, mutually exclusive versus independent events. So what is the difference between them? Okay, some people confuse that mutually exclusive and independent events are same, but they are not. Okay, they are two different concepts. Okay, so if two events are mutually exclusive, what does that mean? What it means? It means that both the events cannot occur simultaneously, meaning at the same time, meaning the intersection between them, probability of A intersection B is 0. Okay, so so the occurrence of one excludes the occurrence of other. It means, yeah, intersection probability of A intersection B will be 0. So this is the definition of mutually exclusive. Okay, so what is the definition of independence? Independent events. So if two events are independent, what it means is that probability of A given B is same as probability of A. Okay, so this is what independence means. So if there are two events A and B, and A is independent of B, meaning that whether B occurs or doesn't occur, the probability of A is not influenced by that. Okay, probability of A given B will be equal to probability of A. So this is what independence means, and this is what mutually exclusive means. Okay, and one more note here. Where is a note? Two non-impossible events cannot be both mutually exclusive and independent at the same time. Okay, so simultaneously. Okay, if there are two non-impossible events, two or more non-impossible events. Okay, it can be more than two as well. Okay, two or more. Okay, so I guess if I say you get it what I mean. Okay, even though I have written two, okay, so you should write in your note that two or more events. Okay, so two or more events, more non-impossible events, meaning what do you mean by non-impossible? It means they are possible. Probability of that event is not equal to 0. Does that make sense? If the probability of, let's say, A is equal to 0, it's an impossible event. If it is not equal to 0, it's a non-impossible event. Okay, so if there are two non-impossible events, and then those non-impossible events cannot be both mutually exclusive and independent at the same time. Both mutually exclusive and independent. Okay, so what do I mean by this? Let me give you an example. So let's take an example of a coin toss. Okay, so if we toss a coin, then there is head and there is tails. Okay, they are what? Mutually exclusive. If head occurs, tail cannot occur. If tail occurs, head cannot occur. They are what? Mutually exclusive. Okay, so yeah, so you know, I don't have to write. So they are mutually exclusive, and at the same time they are dependent. Okay, so they can't be independent, because if it is mutually exclusive, it cannot be independent. Why? Because if we know that head has occurred, then the probability of T occurring automatically becomes 0. Does that make sense? Let's say we toss some coin, and if head occurs, then given that head occurs, the probability of T occurring is what? Tails occurring is 0. I'm not talking about in the second toss. Okay, so I'm not talking about in the second toss. Does that make sense? I'm talking about the same first toss. In the first toss, okay, if a head occurs, the probability of T becomes automatically becomes what? 0. It means they are dependent. How they are dependent? How they are dependent? Because initially probability of T is what? A. So initially probability of T is what? It was half. Okay, and probability of T given at is 0. So it has changed. They are not equal. They should be equal for independence. So if they are not equal, it means what? They are dependent. Okay, so yeah, so they are mutually exclusive and dependent. If it is mutually exclusive, it cannot be independent. Does that make sense? Okay. It will be independent only in the case in which it is impossible. Two non-impossible events cannot be mutually exclusive and independent at the same time. How? Let's say you have two events, and the two events are impossible. I mean, one of them is what? Impossible. Okay, so where is the wiper? One of the event is impossible. Okay, so what I was saying, if there are one impossible event, let's say there is event A, okay, probability of A is something, let's say it is 0.8. Okay, this is the probability of A. Again, it can be 0.8. It is 100%, let's say, or 1. Probability of A is 1, and let's say probability of B is 0. It is for sure you know that A is gonna occur, B is not gonna occur. Meaning 1 is what? Impossible event. 1 is impossible event. If there is one impossible event, then they will be mutually exclusive and independent at the same time. They can be mutually exclusive and independent at the same time. Two events will be mutually exclusive and independent at the same time only if they are one of which is impossible. So in this case, for it to be mutually exclusive, what should happen? The occurrence of one should exclude the occurrence of the other. Okay, so they are mutually exclusive in what sense? Because if this occurs, this cannot occur, and we know only A is gonna occur. Okay, so they are mutually exclusive. They cannot occur at the same time or simultaneously. Does that make sense? Does that make sense? What I'm saying? Huh? It means probability of A intersection B is 0 because they are mutually exclusive. And they will be independent, in which case if this is same as probability of A, it means here probability of B given A is gonna be what? 0. It means probability of B occurring given A occurs, the probability of B is always gonna be 0 because B cannot occur. Does that make sense? It is impossible. B can't occur. It means these two are equal. These two are equal, and once these two are equal, okay, these two are equal, the conditional probability and the ordinary probability, okay, when they are equal, we can say they are independent. It means in this case they are independent and mutually exclusive at the same time. Okay, so two events will be mutually exclusive and independent at the same time when only if they are impossible. I mean, one of which is impossible. Okay, one of them is impossible. Otherwise, if you have two non-impossible events, then they cannot be mutually exclusive and independent at the same time. Okay, so I hope the concept on mutually exclusive and independent was clear. Okay, and you understood this well. So see you in the next video.